We're on lesson 1 of chapter 4, which is ratios, rates, and unit rates. First, we're going to find unit rates. Then we'll find unit prices to compare costs. Then we'll do a real-world application. First, what is unit rates? Well, unit rates tell you the price or the rate or the number per one unit. So for example, this Cheerios box is 14 ounces. You can't quite read that here. And at the store, it's $3.99. So I'd see what is the price per ounce. $3.99 divided by 14. Price per ounces, 14 ounces. If I want to find the unit rate, I would find the amount of price per 1 ounce then. So 14 ounces is $3.99. What I could do is I could divide both of these by 14 or divide $3.99 by 14 to find my unit rate then. So 3.99 divided by 14 turns into 0.285. So $0.28 and then a half a cent. We'll say 0.29, so we'd say 29 cents is my unit rate if the cost is $3.99 for the whole box. What is the price if that box is $4.99 then? Well, it's still 14 ounces, so I would say price per ounce. I would do price, $4.99, per ounce, which would be 14 ounces. And then I could just follow that same formula, turn this into a 1 by dividing it by 14, and then divide that by 14 as well. So $4.99 divided by 14, 0.356. So we'll do 0.36. So this is going to cost us 36 cents per 1 ounce. So 1 would go on the bottom here. So that would be a unit rate. Unit rate finds it when the denominator equals 1. So 36 cents for 1 ounce. Let's do it for rates then. Mickey can type 120 words in 3 minutes. How many words can she type per 1 minute? And I'm going to underline a few things. 120 words, 3 minutes. How many words per minute? I need to find minutes here. So the minutes need to go on the bottom. That's what I need to turn into 1. So for here, I would do 120 over 3, because 120 is the words, and then 3 is the minutes. And since I'm finding it per 1 minute, I need to turn the 3 into a 1. So what I could do is I could divide both by 3. 120 divided by 3 is 40. 3 divided by 3 is 1. So for 1 minute, she can type 40 words. So if I'm going to write this out, I'll say 40 words per minute. Next we have Arnie can buy a 16-ounce box of cereal for $5.49 or a 20-ounce box for $5.99. Which is the better buy? So this is very similar to this here, price per ounce. Which one has a better price per ounce? So we'll just do the first one. It would be $5.49 over 16 ounces. And the second one would be $5.99, and that would be a 20-ounce box of cereal. And then we'll compare the prices per ounce. So this we divide both by 16 to turn the ounces into 1. So $5.49 divided by 16 would be 0.343, so we'll say 34 cents per ounce. So 0.34 over 1 ounce. 1 ounce will cost you 34 cents. And then $5.99 over 20 ounces. So we'll divide both by 20 and turn the ounces into 1. So 5.99 divided by 20 equals 0.299. So we'll say 0.30 if we're going to round per 1 ounce. So per ounce, which one is the better deal? Well, here I'm only paying 30 cents for every ounce of cereal. Here I'm paying 34 cents for every ounce of cereal. So buying a bigger box can get me a better unit rate. So if I was smart, or if I was a smart shopper and like to eat a lot of cereal, because that's 20 ounces, I'm going to buy the $5.99 because I'm paying less per ounce. Let's do a density application. The formula for density is mass divided by volume, and you're going to learn this in science, but it's also good to learn it in math as well. Mass divided by volume. Mass tells you how much stuff something has, how much it, If you have more mass, you're going to weigh more on Earth. And that's how that works. Volume is how much space you have. So how big is your room? How big is your glass? How big is your container? That tells you how much space it has or how big it is. So we have 4 cubic meters of silver, has a mass of, so I'm going to say 4 cubic meters, and I have 41,960 kilograms. What is the density of silver? So we're figuring out density here. So density is mass divided by volume, or mass over volume. Here's the mass, right? Mass of 41,960, so 41,960. And then the volume goes in the bottom, which is 4 cubic meters. So we'll say 4 cubic meters. And then we just simply have to turn both of these into 1. So I divide both by 4. So 41,960 divided by 4 equals 10,490. So per 1 cubic meter, it would be 10,490, so kilograms, per 1 cubic meter. So this would be our new density then. So every cubic meter, which is a cube that is 1 meter long, 1 meter tall, 1 meter wide, would be 10,490 grams, can fit into that. So it's pretty dense. Aluminum weighing 1,350 kilograms has a volume of 0.5 cubic meters. What is the density of aluminum? So here we can underline what we see here. This would be 1,350 kilograms, that's the mass, and then the volume is 0.5 cubic meters. So we need to find the density again, so we could follow that formula. Mass divided by volume. So mass goes on top, 1,350 kilograms, and then the volume would be 0.5 cubic meters. So here I see that this is actually less than 1. So what do I need to do to turn that into 1? Well, I know I can multiply that times 2. I could also divide this by 0.5, which is the same as multiplying times 2. But let's multiply both these times 2 to turn that into 1. So 0.5 times 2 equals 1. Then how about 1,350 times 2? 2,700. So the mass would be 2,700 kilograms per every 1 cubic meter. And there's our density. So which one has a greater density, aluminum or silver? It looks like silver has 10,000 per cubic meter, whereas aluminum only has 2,700. So this is a much more dense material. It fits much more into the same amount of space.